Hi friends, how are you? As we are talking about heat and temperature, there is a necessity of measurement of heat and temperature. In the last episode, we have discussed how to measure temperature. We have three different scales, and we can measure temperature. So now, to measure heat in a system, first we will consider a system that is isolated. First we will discuss there are three type of systems. What are they? The system can be open system, closed system, or an isolated system. What is open system? The system through which energy as well as mass can flow out are called open system. That means mass transfer takes place from system to the surrounding. Okay, I have a system and surrounding. So if mass transfer takes place from system to the surrounding, it is called open system. Closed system is what? The system through which only heat can flow out to the surrounding, but mass remains inside the system. Mass cannot flow out in the form of water vapor or anything. So that type of system are called closed system, in which only heat transfer to the surrounding takes place. And isolated system is what? The system in which either heat nor mass can flow out of the system. That means heat energy as well as mass remain inside the system. That system is called isolated system. So to measure heat, we will consider an isolated system. When the different parts of an isolated system are at different temperatures, then the flow of energy takes place, or change in temperature takes place due to the transfer from higher temperature to the lower temperature part. The heat lost by the part at higher temperature is equal to the heat gained by the part at lower temperature. When a body at higher temperature is brought in contact with the body at lower temperature, there is a measurable amount of heat lost by the hot body is equal to the heat gained by the colder body. That means whatever is the amount of heat gained by the cold body is equal to the amount of heat lost by the hot body. So this is equal because we have considered isolated system. In isolated system, heat do not flow to the surrounding. Therefore, the heat remain conserved inside the system, but the gaining and losing process remains continuous. So one will lose energy, or internal energy, or one will lose temperature and another will gain heat energy. So temperature of the part increases, and this process continue until there is equal temperature throughout the system, or internal energy is equal within all the parts of an isolated system. So a device which can measure the heat energy or heat is called calorimeter. The measurement can be done in an isolated system, and the process of measurement of heat is called calorimetry. Measurement of heat is called calorimetry, and the device which measure heat is called calorimeter. The measurement of specific heat of a solid can be measured by using this principle: heat gained is equal to the heat lost. So from this concept, we can understand the change of states of matter. So when a substance or matter is heated, the state of a matter changes from one state to another, passing through different important points. So let us discuss about the change of states of matter. Generally, matter exist in three states, that is solid, liquid, and gas. So the change of state from solid to liquid, or liquid to gas, or gas to solid, or solid liquid to solid, these are called uh, transitions from one state to another, and these transitions are called change of state. These transitions are called change of state. So as when solid gain heat energy, or when the temperature of the solid increases, solid changes its state from uh, to the liquid state. Okay, again when liquid gain some heat energy, or when temperature of liquid increases, then it changes to gaseous state. Similarly, when temperature decreases, or when heat energy is extracted from the matter, then a reverse process starts. That means when we extract heat energy from gaseous matter, then gases changes into solid, or sometimes into liquid. Then at constant pressure, there is a necessary and sufficient condition to change its states. Similarly, when heat energy is extracted from liquid, also liquid turn into solid. So these are very general conditions which we can see in everyday life. Okay. The change of state from solid to liquid is called melting or fusion, and in reverse, uh, change of liquid to solid is called freezing. The temperature at which solid and liquid, both the state of a substance, exist together. That means there is a solid state as well as liquid in the same time. Then we can say the matter is in thermal equilibrium during the change of state from solid to liquid. That is the thermal equilibrium point at which the solid as well as liquid state exist together. So this is called the melting point, or that temperature at which solid as well as liquid state exist is called melting point of the solid matter. It is depend upon the pressure of the surroundings. Similarly, the change of state from liquid to vapor is called vaporization, and the temperature at which both the state exist together, that is solid, liquid as well as gas, that temperature at which gas and liquid both exist together is called boiling point. The temperature at which solid, liquid and gas exist together is called boiling point. But some solids do not passes through liquid state while um, changing of states takes place. So in that case, solid directly converted into gas or into gaseous state. So this process is called sublimation process. In what is sublimation? The process in which solid directly converted into gas by gaining heat energy is called sublimation. For example, dry ice, that is solid carbon dioxide, camphor or naphthalene ball. Dear brother and sister, when we draw a graph between heat and temperature during the change of state, we have seen that uh, the extra amount of heat is required during the change of state. the extra amount of heat is required during the change of state, but uh, the increase in temperature is equal to 0 for that amount of heat. That means temperature do not increases for that amount of heat. We cannot plot that temperature in respect to the amount of heat required to change the state. That means um, the amount of heat that is hidden remain hidden during the change of state. So that amount of heat that is remain hidden and cannot shown in temperature scale is called latent heat. The meaning of latent is hidden itself. So we can say that the amount of heat that is required to change the state of a substance is called latent heat. We cannot plot that heat versus temperature graph. So the importance of latent heat is very much great, because they do not show but they do work. Okay, that means the change of state takes place due to that amount of heat. Okay, so latent heat is there while transition from solid to gas, as well as from liquid to gas, or from solid to liquid to gas. So that amount of heat can be measured as by calorimeter, and the expression for the amount of heat is equal to Q equal ml, where m is the mass of the substance and L is the latent heat. The latent heat value depend upon the what type of the material it is and how much temperature how much heat is required to change the state. For example, from ice to liquid, how much energy is hidden in it, or from water to ice, or from water to water vapor, how much heat is required to change liquid state to the gaseous state. So that amount of heat is called latent heat. So latent heat is measured in SI unit as joule per kg. Joule per kg. So the latent heat for solid liquid state change is called latent heat of fusion, and the latent heat for liquid gas state change is called heat of vaporization. Latent heat of vaporization. So while solving numerical problems regarding state change, first we have to take into account the increase in temperature, uh, the amount of heat required to raise the temperature of the material by expression Q equal m s delta T, where m is the mass of the substance, s is the specific heat of the substance, and delta T is the required raise in temperature. Also, to take into account the change of state, we have to use latent heat of vaporization or latent heat of fusion. So amount of heat required to change the state, the amount of heat required to change the state is equal to Q equal ml. So that amount of heat is required to change the state of the substance. So if one is asked that what is the amount of energy required to raise the required to change the state of a substance, then we have to add both the expression, that is Q equal ms delta T and Q equal ml. Both the expression, on adding both the expression, we get the amount of heat required to change the state of the substance.